Muhammad Rahman bin Abdul Aziz from matrix CE200209. First, I will explain about the X data and Y data. For X, altitude, and for Y is pressure. This is our independent variables, and then this is dependent variables. This is independent variable because the altitude will cause the pressure to affect this value of data Y. Let's move to the means. How to get the means and standard deviation. For the mean first, for mean x1 for altitude, this is a formula to get the mean. We type count and we drag from this until the end and press the enter, we get the number of the data. For x1, we use the average coding and then drag from above until the end and then press enter, and we get the value of mean for altitude. Mean x2, same formula like mean x1. Next, we go to the standard deviation s1 for the altitude, which is this is our formula. For the coding, we choose STDEF for the coding standard deviation, and then we drag for 30 data x until the end, and then we enter this, we get the standard deviation of altitude, and this s2 of standard deviation pressure same as coding s1. Now let's move to the minimum and maximum values for altitude, which is this. We use the mean of coding of Excel and drag on the altitude, and then we enter, we get the minimum for this data and maximum, so max and drag, and we get the maximum, same as method for pressure. Now we move to the scatter diagram, and I will show how to get the scatter diagram. This is select the data from the pressure. I edit from this, we put the pressure name, and then we put this data value, drag all this data Y, and then after we drag data Y, the data of our value will input in this table, and then to input the data X, we edit, and then we drag all the data X, and then we'll put the data at table, and then okay, and it will produce our scatter diagram, which automatically after that search our regression line. We choose the select data, we take X and Y value and get our regression line. This is our slope for the regression line, and this is our intercept, and then this is our determination of Pearson that automatically produced from this regression line. This slope and intercept is using this slope coding and drag for 30 data Y and 30 data X, and this is intercept coding, drag 30 data Y and 30 data X. Then we move to the least square method, which is first total it for X and total it for Y, for X data X and data Y, and then for X2 square for the X data for each value of this X data. First we did it for this value, and then we copy and paste to all. It automatically will and edit for it. Same as Y2 at total at low, which is this value using a sum coding before is which is using a sum. And then for XY, for this we using a formula to multiply, and then we sum X and Y value, and we move to the next. This is our formula, and then we put our formula from this equation, and then we using this formula to get the final answer for SXY, which is minus 130 we get from here, and then multiply with table 001, this multiply with this Y, and then we get the answer, which this is SXY, SXX, and using this formula, and then we input into this, we get to the final answer, which is this table get from here, and then this minus and 1 divide with 30, and then multiply with X, and then need to square it, and then this is final answer for the SXX. Beta 1, which use the formula XXY, XXX, which is XXY, XXX, we get that final answer before, and then we need divide XY, XXY and XXX, and then we get the value of the final answer be beta 1. And then for the beta 0, we need to use this formula, and then for Y is 30, and then minus with this beta 1, and then multiply with this x and divide with 30, and we get the value of our final answer beta 0. To sum up, we conclude into this equation for a slope, and it will be like this. This is our intercept, and this is our when the altitude is increased by 5%, the pressure content will decrease or by 0.575%, and negative 0.11, same as at the table regression line. We get the negative value because our regression line is decreasing gradually. That's all for me to demonstrate this video, and thank you.
Hello, my name is Leong Chisa, matrix number CE200193. So I will be explaining the simulation result for the hypothesis testing. So first here is the given question, the alternative hypothesis, beta 0 not equal to 0, beta 1 not equal to 0. So we have two alternative hypotheses. So not equal to 0 means it is a two-tailed test. So alpha equal to 0.05, which is 5% significance. And then V equal to n minus 2 is the formula. N is 30, minus 2 we get 28. And then, so we are doing t-test, so we need to find V and alpha over 2. So alpha over 2 is 0.025. By doing the t-test, referring from the t-test table, 0.025 and 28. So table 7, 0.025 and 28, we get 2.048. So we need to have the positive and negative value since it is a two-tailed test. So next we need to find SYY. The SYY formula is shown here, which is 30. So we will get 648.32. Next we need to find the SSE, which is the sum square error. So by using the formula SYY we find previously here, minus the beta 1 multiplied by SXY. SXY is L8. LXL, which is negative 5609. So we'll get 5.58. So moving on to the MSE, which is the mean square error. So by using the formula SSE, sum square error that we found earlier, divided by n minus 2, which is also equal to the V. So we'll get 0.200. So right now we will do the hypothesis testing for the beta 1. So by doing this, we use the formula t-test, beta 1 minus beta c, and then divided by the square root of MSE. MSE is 58, and then divided by SXX. SXX is L17, belongs to here, 48963.141. So we'll get negative 56.748. So negative 56 is somewhere here in the rejection area. So we can summarize that this we will reject the null hypothesis. B0, we can find the t-test first by using this formula. We'll get the t-test for B0 is 1476. So by looking at this diagram, 1476 is belong to somewhere here. So this is also inside the rejection region, so we will reject a null hypothesis. We can calculate this by using the formula SXY divided by the square root of XXX multiply SYY, and then multiply SYY, D57. So D57 is here, SYY 648. So we will get negative 0.995. Summarize that it indicates a strong negative linear relationship because we have negative, almost negative 1 here between the variable, which is the altitude, and the pressure based on the thesis. Square we can find by using the formula, so we'll get the answer of 0.991. So we can summarize this by saying that 99% of total variation is explained by the regression line using the independent variable cost. That's all from me. Thank you.